Hey everyone, Dr. P again, and in this lecture video we're going to start taking a look at the SN1 reaction. In particular, let's look at the mechanism of the SN1 reaction. So, just to review here, our SN1 reaction has first order kinetics, and it has a unimolecular rate determining step. So, for example, if we had CH3 3CBr plus I minus, and we got CH3 3Ci plus Br minus, if we drew an energy diagram here, reaction progress diagram, we'd see that we might start with our reactants here, CH3 3CBr and I minus, and then we'll go ahead and our rate determining step is going to be our loss of the leaving group. And so in here we'll have our intermediate. And in this case it's CH3 3C plus and I minus and Br minus. And then at the end we'll have our CH3 3Ci and Br minus there. Okay, so what does this mechanism look like? Well, let's start out here with our T-butyl bromide. And the first step is our loss of leaving group. And that's going to be our rate determining step. Now we also have I minus present because we started with that, right? So that can then come in and attack, and we will get now our product, which is T-butyl iodide. And again, our rate determining step is loss of leaving group. Okay, that's this first step here of the largest activation energy. Okay, now what are some characteristics and conditions, features of the SN1 reaction? Well, let's take a look here. I'm going to keep that in frame, and we'll look at some characteristics of the SN1 reaction. Okay, first of all, a weak nucleophile is okay. We do not need to have a strong nucleophile. However, like SN2, we need a good leaving group. And then we also need polar protic, or we could just call it protic, solvent. For example, like ethanol, CH3, CH2OH. Water, methanol, something that has that hydrogen attached to an electronegative atom. Okay, we can look at some, maybe some little details here. So looking at, for the good leaving group here, if I had CH3, 3C OH plus Br minus, that would give me no reaction. But if I had CH3, 3COH plus HBr, my H can protonate that oxygen, and now I'll get a good leaving group. And we saw that in the last lecture, looking at leaving groups for SN2 reactions. So we could protonate to make a good leaving group, and that will now give us CH3, 3CBr plus H2O. So we'll say here protonate to make good leaving group. All right, so that we can get around having a poor leaving group sometimes. All right. Let me just show a sample mechanism. Let me show a sample mechanism here of a protonation to make a good leaving group. So we'll take this example. So I'll go ahead and I'll have carbon, CH3, 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 OH, lone pair, and then I'll have my HBr. And so the first thing I'll do is grab that proton using one of the lone pairs from the oxygen. And now, and I've got Br minus floating around here too, don't want to forget that. Now my leaving group will leave, and I'll make that carbocation, just like I did in the previous mechanism. Okay, and I've got my Br minus, and I've got HOH, because that was my leaving group, that came off there. And now my bromine can go ahead and attack, and I will get my final product here. So I'll get my 2-butyl bromide and my water. Now, if I was going to look at the reaction progress diagram, it would look something like this. I've got 1, 2, 3 steps, so I should have 3 peaks. So typically I'll have my initial protonation, and then I'll have a much higher peak for loss of leaving group, and then I'll have my nucleophilic attack. So this is my protonated species here, and in fact maybe I'll color code these. So this guy here is in there, and then my carbocation is that species there. Sorry about that. So we go starting materials, reactants, first intermediate, second intermediate, product. So we've added a step. And these protonation steps can occur. You could have a later protonation step if you have a weak nucleophile, like an alcohol. You're going to need to deprotonate at the end. And we'll look at some examples of these later on. It's conceivable that even in an SN2 reaction, you could have a protonation required to make a good leaving group. But typically it's found in an SN1 reaction. So the base SN1 reaction has 2 steps, but when you add in a protonation, now it's 3 steps. If you had a weak nucleophile attacking, you would then need to deprotonate that later, and you could get a 4th step. And you could also get rearrangements, and that could be a potential 5th step. And I think we'll leave that for the next lecture video. I'll talk about the substrate in SN1 reactions and what makes a good substrate for an SN1 reaction, and then talk about why rearrangements can occur. All right, so until then, stay safe. Bye now.